Thanks for joining us. And this is our first Scientist and Strategist series of the academic year. I'm Audrey Kurth Cronin, Trustees Professor of Security and Technology, and I'm Director of the Carnegie Mellon Institute for Strategy and Technology, or CMIST for short. I come from a Navy family, can you tell that? We're a university-wide initiative focused on the smart development, use, and governance of emerging technologies that are changing the landscape of war and peace. We created this speaker series in order to bring together scientists and engineers on the one hand, with strategists and policymakers on the other hand, to foster engaging in-person discussions about their work. In the past, we've covered all sorts of topics, from the impact of new technologies to the fight for gender equality in STEM. Today, we're lucky to have two fantastic speakers who have shaped national policies in energy innovation and cybersecurity, both as public servants, and they're now driving strategic research right here at Carnegie Mellon University. And we're thrilled to have them both. Costa Samaras is a systems engineer and a national leader in energy and technology policy. At the White House, Costa played a key role as Principal Assistant Director for Energy and Chief Advisor for the Clean Energy Transition at the Office of Science and Technology Policy, helping guide the nation toward a more sustainable future. Right now, as Director of the Carnegie Mellon University Scott Institute for Energy Innovation, Costa is pushing forward pioneering research and solutions in energy. Costa is also a professor of civil and environmental engineering and mentors the next generation of visionaries here at CMU. And I believe we have some of those visionaries here in the audience. We're expecting a lot out of you. I know you're not going to let us down. Now, here's something remarkable. In his early days as an engineer, Costa contributed to the number 7 subway extension in Manhattan and played a role in rebuilding the subway under the World Trade Center after 9/11. Did we get that right? Thank you for your service. Costa's work blends cutting-edge technology with national interests, and we're delighted to have him here with us today. Welcome, Costa. We're also, thank you. We're also joined by Harry Kresa, who is the new CMIST Director of Studies in our Washington, D.C. office. And oh, by the way, students, if you don't know about our Washington office, I highly recommend that you look into our Washington semester program where you can live, intern, and study for a semester in Washington, D.C. It's incredibly cool, and you can learn how to make a real impact on policy and get involved in public service in addition to all the incredible things that you're learning and potentially doing in either technology or social sciences or engineering or any of the other things we teach about. Washington semester program, you heard it here. Harry was the Assistant National Cyber Director for Strategy and Research at the White House, where he played a leading role in shaping the Biden-Harris administration's national cybersecurity strategy. He led efforts on international policy and great power competition, while also co-chairing a government-wide effort to secure important technologies for the clean energy transition. At the Department of Defense, Harry developed strategies to disrupt adversary cyber campaigns and managed military cyber policy in the Indo-Pacific. With deep expertise in U.S.-China competition, Harry's journey has taken him from his rural roots in Iowa to Nanjing, China, which was his very first taste of city living. Along the way, he's also made significant contributions and had impact at the Cyberspace Solarium Commission and the Center for a New American Security. So please welcome Harry. Now, since we have two speakers today, we've asked Costa first to give a short introduction about his background and his current work, and then to be followed by Harry doing the same thing. And then after that, I'll sit down with both of them over here for a longer panel discussion, and then we'll finish with some audience Q&A. So that's our plan, and let's get started. Costa. Thank you for being here.
Thank you so much for having me. Well, welcome everyone. It's really an honor to be here with you. Thank you to Professor Cronin, to CMIST, to Carolyn, to Ralph, and the entire CMIST team for really elevating the amount of attention that this critical issue, cybersecurity and the clean energy transition, deserves. I am so excited about the work that's happening at Carnegie Mellon and the work that's happening in the Scott Institute. So the Scott Institute is our university-wide energy institute. We are the home for all things energy research at Carnegie Mellon. We are enabling the solutions that are going to get this country and the world down to zero emissions and enable a better future for everybody. Now, we have more than 160 faculty affiliates at Carnegie Mellon. That's more than 10% of the faculty is doing something that's interested in energy. Carnegie Mellon University is an energy powerhouse, and we're very lucky to work across all of the schools at Carnegie Mellon to really work together to get stuff done. So what do we do at the Scott Institute? We solve problems. That's really the Carnegie Mellon ethos. It's like we get it done, we solve problems. These are technologies, systems, policies, all the things that we need to accelerate the transition to a net zero and climate resilient future. How do we do that? Well, one, we give out money. So researchers here, we would love for you to be participants in things that we're doing on campus where we're giving out seed money. Somebody has an interesting award. We're kind of like a little DARPA or an ARPA. Somebody has an interesting idea that really is not ready yet to go to a funding agency and they want to spend some time thinking about it. We give out these little genius awards. We also create and accelerate bigger climate and energy research initiatives. So we want to grow the amount of climate and energy research that happens at Carnegie Mellon, and we help do that with our convening and strategic investments. We're also the home for climate tech. And so Carnegie Mellon it has an entrepreneurial spirit. We help accelerate opportunities for CMU, clean tech, and climate tech founders. And then finally, we're the energy and climate community. So we really want to be a home for all the students, staff, and faculty around Carnegie Mellon to gather, to collaborate, and yes, to have snacks around issues around climate and energy. We have an annual Energy Week in March, and you're all invited, but we have events throughout the entire year. So Carnegie Mellon has deep expertise in climate and energy, and some of the things that we have a good comparative advantage in is stuff that you might think: AI, robotics, computing, and how those affect energy, how those both affect energy use and climate outcomes, but also how they drive some solutions to those outcomes. We have also, being in Pittsburgh, you would think that we're good at advanced decarbonized iron and steel, and you'd be right. And so we have a long history at Carnegie Mellon thinking about ways to decarbonize heavy industries like steel. We also have a big expertise across the university in buildings and building electrification and thinking ways that we can have smart, efficient, and healthy buildings. And then we are very good at transportation. So the ways that we think about transitioning to electric vehicles, to personal mobility, to automated vehicles. And then finally, we think about materials and science like hydrogen and electric fuels, advanced catalysts, all the things that come out of our engineering and science departments that collaborate with our great social sciences here. And so that's a theme that I want to make sure comes through here, is that Carnegie Mellon has really set the standard on how engineering, science, and social science and humanities can work together to solve big problems. And that's really one of the big honors that I'm here collaborating with CMIST. And I think that this is the foundation of a much broader collaboration around energy and climate around the university. So, all right, this is page 1 of 30. All right, I'm kidding. As Professor Cronin described, I was in the White House. I got to work with my great friend Harry on a bunch of different issues around AI, around electrification, around digitization, around fusion and nuclear power, supply chain resilience. It's basically the White House is small enough that that Harry and I and our colleagues kind of probably had to do a lot of everything. We know that climate is driven by carbon pollution. We know that carbon pollution is driven by fossil fuels. Our job is to figure out how to get emissions down to zero, and then really beyond zero and get it to net zero. The Biden-Harris administration rejoined the Paris Agreement on the first day. And so what that did is made a commitment for the United States to get 50 to 52% below our 2005 emissions levels by the end of the decade, 2030. Not that far away. But the administration also made a commitment to getting emissions down to net zero no later than 2050. But the way, as Professor Cronin mentioned, 100 years ago I was a civil engineer. And so I like to think about the climate challenge as a mega project. So we build subways, and when we build subways, it's like, right, what do we need? How long does it take? Who are the people that we need? What are the machines that we need? And then how do we make it work? So a mega project like building a subway is not unlike the climate challenge. However, the climate challenge is a mega project that happens in every place, community, city, country in the world, all at the same time for the rest of our lives. And if we fail, we're all going to suffer more, right? So no pressure, but it's the climate challenge is, the way I think about it, is the largest mega project in global history, and we should start thinking about it like a mega project. So I want to talk about very briefly 3 things that help me frame this challenge out: time, assets, and choices. So first, we can make more money, but we can't make more time. So 2050 is 25 years away, and so for the more senior folks in the room, you might remember that the time between now and 2050 is shorter than the time between now and 1999, when the group Smash Mouth released their magnum opus All-Star, right? So basically, we have that window between now and 2050 to get the entire world's emissions down to zero. So we need to know the schedule, right? This is like we have the time frame. Now we need to know the schedule. So my old boss at OSTP, Dr. Prabhakar, would say, when faced with a hard challenge, what does it take to get it done? So what does it take to get the climate challenge done is a lot of assets, or we can think of it as stuff. And so we all have too much stuff, but in this context, I'm talking about the things that we'll need, the physical things that we'll need to get us down to zero emissions: solar panels, heat pumps, electric vehicles, electrolyzers, steel plants, batteries, e-bikes, insulation, windows. Like all that needs to be made, and where it's made, how it's made, the security of that installation, and the cost, the equity, the jobs. That is part of the mega project. So take just EVs, for example, electric vehicles. Electric vehicles have been really rising in the amount that we're selling in the United States. Last year, 1.4 million electric vehicles were sold, which is an amazing record. It's great. And so the way we can look at that and look backward and say, nice job, where do we need to go from here? So in a decade, we'll need to take that 1.4 million and turn it into 15 million. And so we basically need to add the capacity to make and sell and use another million electric vehicles every year for the next 10 years. And so larger trucks, like medium and heavy-duty delivery trucks, the amount of electric and zero emissions medium and heavy-duty trucks that we sold last year, 3,000, right? Not a lot. And so we have to take that 3,000 and get it to several hundred thousand by the end of the decade. So that's supply chain, materials, workforce, equity, capital, labor. Everything rests on electrification, right? And so after the last 15 years of basically flat electrification demand growth, we're going to need a lot more electricity, even while we're doing lots of energy efficiency. So we might need 30 to 50% more electricity by 2035, and that's on top of any new demands that we might see from AI and data centers. And so the system has to be affordable, reliable, climate resilient, and clean, as well as making sure that it doesn't leave anybody behind and that everybody has access to this life-saving critical infrastructure. So we're going to need to, we've been growing solar power like crazy. Maybe you heard, so because of the Inflation Reduction Act, solar power has really been now will be the major source of electricity that we're installing in the United States this year. 95% of the energy assets that are going to be installed in the United States this year are going to be clean. But we got to take from those winds and grow it by 5x in the next decade. We're going to have to take all of the storage that we started putting in. You may have seen an article recently of the amount of energy storage that we're putting in. That has to grow by at least 3x. And then we're going to have to double interregional transmission and 5x regional transmission. Again, stuff. And so I want to start, so we had schedule, we have stuff, and the last thing is choices. So how do we deal with uncertainty? How do we deal with good surprises and bad surprises? We at Carnegie Mellon have leaders in social sciences and behavioral and decision sciences to help us think about making the right, robust decisions under deep uncertainty and making sure that the technology like AI and emerging tech works for everybody and is secure and improves people's lives. We need a new era of deep collaboration between the social sciences, the physical sciences, the arts, and the humanities. And this is something that Carnegie Mellon has been doing for 5 decades. And so luckily, we just have to replicate Carnegie Mellon's formula and grow it nationwide. And we have to think about the distributional equity issues at every step along the way, not just at the end when a new technology is around, but in the beginning when we're doing the innovation. We want to make sure that everybody can see themselves in the energy transition and that there are good paying jobs that enable a coalition that is durable and reliable. So one thing that I kicked off in the administration is this concept of a federal energy transition capability assessment. We really need to know where we've been, where we are, where we're going, and then also where we need to go is something that we need to be doing. So while there's a lot more to do, one takeaway, I'll finish here, is that a lot of the good ideas that we at Carnegie Mellon and really the broader climate and energy community have been working on over the last 30 years have gotten done in the Biden-Harris administration. And so more than $910 billion has been invested in the clean energy economy of the future. I led the team that built the assessment for how many clean power plants that have gone in. It's more than $167 billion in private investment, and you can track that on invest.gov. Basically, before the Biden-Harris administration, we had no chance of meeting our climate policy agenda or climate commitments by the end of the decade. Zero. Thanks to the actions that are now in place, we have a chance. Right? So we went from no chance to a chance, and we will have double the amount of clean electricity, and emissions reductions by the end of the decade than we would have before, thanks to the climate laws that were put in place. We need research and innovation, like the kind that's done here at CMU, to help us get us to net zero faster. Let's celebrate all the wins that we've had, and now in true Carnegie Mellon fashion, let's get back to work because we have another Inflation Reduction Act to get done. Thank you so much. We're looking forward to the discussion.
Thank you all for being here, and thank you, Professor Cronin, for that wonderful introduction. Indeed, in comparison to Costa's really important work on the biggest mega project that humanity has ever undertaken, I started my career in the much easier to navigate and more tractable issue of managing U.S.-China relations. And so that's where I began my policy service world, and I began my life in a U.S.-China economic and technology competition sort of analysis space. I worked in think tank land in Washington, D.C., and that technology and economic competition work in the 2010s started to shift decisively in the direction of cyber policy. As in that era, the kind of full scope and scale of the cyber-enabled espionage by the People's Republic of China became more clear to the broader public and policy community. And so took up a lot of my brain space at that time and a lot of policymaker attention, but even so, there was a lot of debate about what we as a U.S. government and a policy community should do about it. The United States was seen as having some of the most sophisticated cyber capability in the world, but was very focused on restraint when it came to cyber capabilities and military use and operational use of cyber capabilities, because the community was unclear how those capabilities would be interpreted. In international relations and foreign policy spaces, there's a lot of concern about signaling and what messages you're trying to send with what kinds of activities. And while we were seeing a lot of efforts from the PRC government to expropriate sensitive information from the US government, and we were starting to see efforts by the Russian and Iranian governments to sow discord in the American public, there was a concern that anything we might do to push back against that in the cyber realm, any cyber operations we might pursue, would itself be escalatory, would cause a out of control, spiraling tension sort of scenario. And so the best action, it was agreed upon fairly universally at the time, was that we should just absorb it. We should just take it and not think about throwing any other punches, because we didn't know what would flow from that. Then, of course, the 2016 election campaign happened. And Russia's cyber-enabled efforts to influence the 2016 presidential campaign sort of shocked the policymaker community into rethinking that assumption, to wondering whether our restraint in fear of escalation had unintentionally been escalatory. That by not acting, by not pushing back against the Moscow and Chinese government's efforts to hurt American interests via cyberspace, we had unintentionally sent the message that they could continue doing so without bearing a cost. And so that was a happy-go-lucky time for me to get recruited into government and get to work at the Department of Defense on how we should update our posture and thinking on that. I got to use my background as a China hand and Asia analyst to both work on new military and strategic doctrine for these cyber operations, the new legal authorities that were giving the military permission to make a more forward-leaning posture in cyberspace, but also work with allies and partners throughout the Indo-Pacific region on technology, security, and strategy more broadly, to try and persuade them to see the world in our preferred way, and how we think about openness and transparency in our technologies as a key enabler of security, of collaboration and information sharing as a source of strength and resilience into the future. And that ended up being part of a big shift in overall government posture and culture towards cyber policy and technology security policy writ large, seeing it as a bigger picture undertaking with lots more participants and stakeholders in it than something that should be hidden in a closet because it's too scary. That if we were to talk about the vulnerabilities or what we should be doing as a result of it, that would make those vulnerabilities real. And it turns out that those vulnerabilities will be real whether or not we confront reality. When the administration turned over and the Biden-Harris team came in, the policy discourse around technology security and the technology agenda more broadly, I think was in a place where it benefited from both a greater clarity of threat, but also a greater sense of ambition, more openness to the kinds of mega projects that Costa mentioned. On the clarity of ambition side, there were hard-won lessons from that 2016 forward period, but also at the very beginning of the new administration, you had a number of prominent cyber incidents that drove that message home, both for the young administration and for the broader public. You had the SolarWinds supply chain attack, where hackers associated with the Russian government inserted malware into software updates that you are supposed to trust, that you should always update your software to get the latest security unless the Russians happen to insert something malicious inside. And that affected thousands of government agencies around the world. Then, of course, the real sea change came from the Colonial Pipeline ransomware attack, where criminal groups launched a ransomware attack against operators of an important gasoline pipeline on the East Coast and caused a brief but serious gasoline disruption and minor panic of the kind that we had not seen in decades. And of course, later on, and earlier this year, it was revealed more widely that a group called Volt Typhoon, operating out of the People's Liberation Army military, had been hacking into the American electricity infrastructure and placing destructive malware for use during a crisis to cause societal panic and destabilize our electricity supply. And so it has become there's been this greater clarity of the threat we face in this space and why a brittle digital ecosystem is an intolerable risk, especially as we move into a more digitally enabled and advanced manufacturing-oriented society. But at the same time, the good news is we also have a greater sense of ambition when it comes to our technology agenda in this country. You've seen that through these major legislative accomplishments from this administration, from the Inflation Reduction Act, the Bipartisan Infrastructure Law, and of course the CHIPS and Science Act, that illustrated a greater interest in direct intervention into the economy than had previously been fashionable in the modern era. What the administration called a modern industrial innovations and modern innovation and industrial strategy, and a willingness to say the market is not achieving all the outcomes that we need to see happen for our national security, but are not being organically realized, and so we're going to be more open to nudging here and there to get to those outcomes. And we've seen that have a great effect between those three laws in transforming a lot of our major policy outcomes and priorities across the economy. Costa mentioned the clean energy mega project we're undertaking. We're seeing, for the first time, gigantic new numbers of manufacturing investment coming online across the country, both in the clean energy sector, but also in semiconductors and other forms of advanced manufacturing. The infrastructure law also was an early down payment on a lot of those clean energy priorities, including in vehicle electrification, where we're not literally priming the pump, but there's a pump analogy in there. So we have seen what the government and policy community is willing to do, what kinds of risks it's willing to take to achieve specific outcomes grow. Just at the time we're getting that better sense of threat. But indeed, those agenda items that we've discussed here are disproportionately dependent on a digital ecosystem that has the security and resilience necessary to deliver it. And I think the clean energy transition is one of the best illustrations of that dynamic. We increasingly have learned over the last few years, and I remember when Costa and I first met early in the administration, we were discussing how it increasingly looks like decarbonization is inherently digitization. Clean energy technologies, in the vast majority of cases, are much more technically sophisticated and digitally interconnected than the technologies that they are replacing. This is opening up gigantic new opportunities and innovative approaches to energy abundance and efficient use and transmission and storage. And if we do it right, can also be a vehicle to clear out technical debt in the rest of our infrastructure. And we can harness the clean energy transition to refresh our broader critical infrastructure ecosystem that in a way that it would not have before. But if we do it wrong, then we could find ourselves in a situation where we are hooking the internet up to every part of our critical infrastructure without the security necessary to have the confidence to do that safely and grow instead the attack surface, the opportunities for bad actors to get in and cause problems, especially now that we know that criminal groups, they know that critical infrastructure is a good place to target with their ransomware attacks because of the relatively low tolerance for delays in getting it back online. But also governments have demonstrated their interest in being able to destabilize critical infrastructure, our critical infrastructure. Other countries, some of the first digital physical consequences we saw of this was in Ukraine in the mid and late 2010s when the Russian government was able to make turbines explode on the Ukrainian power grid using purely cyber attacks. And we have seen more electronics exploding recently, and a good reminder that as the digital ecosystem increasingly defines our day-to-day life, we need to have confidence that that ecosystem can support it in a secure and reliable way. And I know that it is places like Carnegie Mellon University where we're going to have to reckon with those the consequences of that digital physical convergence, but where we also have the best promise in doing so. One of the things we learned in government was that the relevant stakeholder communities to this transition, who are thinking about both the risks and opportunities, are not talking to each other as much as they should be. The affirmative vision agenda setters inside the government were not articulating what they wanted to achieve in the same rooms as the glowering national security people who would know how to control for the risks that might provoke. And in the reverse, those glowering national security types were apparently not imbibing those parts of all of President Biden and Vice President Harris's speeches about where we were going. There were too many people being surprised that, wait, we're going to be doing what with this transition? How many things are getting connected to the internet? And that lack of communication was a big hurdle that we worked hard to overcome. But now we also need to make sure that that hurdle is overcome outside of government. As things get more and more digitized, we're also going to depend more and more on industry and civil society to carry forward the rest of this transition. We need to make sure that all those new entrants who are bringing vibrant new ideas and dynamism into the clean energy space are able to also quickly get up to speed on the security and resilience needs that they need to bring with them, the types of risk that their fossil energy counterparts have had decades more time thinking about and preparing for. And it is communities like this who can cross that scientist and strategist divide, who can think about the policy solutions and the technology solutions that need to go hand in hand to cross those chasms, that we really need to approach those issues. So I'm really looking forward to this conversation today, and I'm looking forward to all the solutions that the CMU community is going to bring to this interesting challenge.
Me too. All right, would you mind joining me up here, please? See if I can climb up on this chair. All right. I'm going to start out by asking you both to spell a few things out for those of us that are not from either the cyber background or the energy background, and explain maybe with some stories or examples or a little bit more fleshing out, why is it that so many legacy fossil fuel or earlier type energy companies are moving away? What are the incentives and disincentives from moving away from the classic air gap between information systems and operating systems and toward digital connection? I mean, obviously new things that we're building have that incentive, but what about the legacy industries? Are they also moving in that direction? And is that another way that we're shifting the entire energy infrastructure? And are there any stories that you can share that show the downsides or upsides of doing that?
Want to start?
Sure. I think that Costa, you had mentioned good surprises and bad surprises during this transition, and I think one of the bad surprises was that the permitting and siting process, the ecosystem around building things in this country, is not keeping up with a lot of our greatest ambitions. I think that some of the early models, correct me if wrong, for the clean energy transition and how things like the Inflation Reduction Act would push it forward, counted on a lot more interregional transmission than we're getting because of local zoning, because of local permitting siting, because of delays in interconnection. We're just not getting that kind of transmission between regions and subgrids that we had hoped would materialize. The good surprise is that there are tools that are helping balance that. Batteries have ended up following a more aggressive cost curve downward than even the rosiest optimists or rosiest projections from a few years ago. And so the battery storage has become a much bigger and boominger industry than had originally been anticipated. But those are also much more digitally dependent than traditional energy infrastructure is. They have much more onboard software control, and they are feeding into programs like tools like virtual power plants, which is basically software-defined granular control of where electricity goes on the grid, right? So the role of software in controlling our electricity and telling it where to go and storing it and redeploying it when the sun isn't shining or wind isn't blowing is becoming a bigger task for utilities and power providers across the country. That is great news. It's solving a big problem that we have, intermittency and the lack of transmission, but it's also bringing a lot more software onto the grid. But also I know that, like in Texas, they're building tons of batteries not even associated with clean energy production. Like batteries, turns out, are great for lots of issues, regardless of whether you're talking about clean energy. And it is an irresistible tool of stability, of profit maximization that is software defined.
Great.
Anything to add, Costa?
Well, I mean, I think it's important that we remember, or at least we recognize, that in most cases, digitization, it helps us. I mean, if you all may not remember, like before maps on your phone, we had like a piece of paper. We had to like look at it where we're going. We didn't know if the traffic was coming, like what the traffic was like. So we can think about ways that digitization has improved our lives, absent just the threat of malicious actors taking advantage of those freedoms and wanting to do the system or us harm. On the grid, the grid has operated as the world's most important machine for more than a century, but we didn't really have a good sense of what was happening out there. We would kind of have checkpoints along the way, but we didn't really have any great intelligence from an operator's perspective of where the congestion was, how we might be able to alleviate the congestion, and digitization tools that are already deployed and that could be deployed help manage those resources and get electricity to where it needs to be in the most efficient and cost-effective way. Now, that also introduced this threat vector, right? This attack surface that Harry talked about. And in the 2010 attack on the electricity grid in Ukraine, the story that was in the newspaper was the only way that they were able to get it back up online sooner than later, because the digital part of the grid was corrupted, was that there was a set of switch gears that happened to be old-timey, like cartoon switches that would throw up and down and like the sparks would fly. And the only way that they were able to do that is that they had tacit knowledge in the engineering workforce that said, these old switch gears are a bypass. We're going to physically use our hands to throw the switch and make it happen. And so they were able to get the grid back online. And so there are legacy infrastructure that add new technologies that actors hope are good or like painted on top of them without a long-term realization about how that opens not just new opportunities, but new threats.
But just to follow up on that, I mean, if that was important to have a legacy, switch that you could throw, just as a kind of a devil's advocate here, I mean, why wouldn't you want to say, like my grandfather might say, you stick to the old switches, and this is a bad idea to be so connected. And how do you argue against that kind of, I won't say it's common sense, but backward-looking perspective?
And I think the last 40-ish years, we've taken on a posture of optimization. Now, I'm an engineer and I love optimization, but optimization works on paper, but in the real world, in infrastructure systems and in decarbonization and in security, what we want is optimization with a redundancy constraint. What that means is like a backup. And that no doubt costs more, right? When we have backups, when we have redundancy, it costs more money. It's less efficient. And good policy, good security has a balance of efficiency and redundancy. And so that's where we are think of the way that we move forward in resilience, both for climate and for bad actors, is where can some things be, as some of our colleagues from our collaborators have called this, where can we have things that are safe to fail? And how do we respond? Resilience is all about how fast you can come back up after you have an event. And how fast we can come back up, whether it's the power goes out or water has a challenge, is a function of what are the options that you have open to you that haven't been closed off. And that switch in the Ukrainian power grid was an option that was probably legacy left there, not for any reason other than it just wasn't removed. And so we need to be adding those types of redundancies in order to be resilient going forward.
I think you can, if I
Go
can
ahead.
Jump in, I think you see a greater acceptance of inefficiency in the name of resilience inserting itself in a lot of the industrial strategy initiatives of the recent years. And I'm thinking a lot about like supply chains and the brittleness of advanced manufacturing supply chains in particular that exposed itself during the pandemic, where a lot of countries around the world, ours included, are now thinking about how, well, maybe just-in-time inventory is not the best way to handle our most critical materials and products. And that means sacrificing some of that like McKinsey procured extreme efficiency, threadbare margins of timing and inventory in favor of resilience. And that sometimes a pure market approach is not going to produce those outcomes, and you need good policy to say, we need to accept this inefficiency, and we'll thank our prior selves for that later.
It needs to get paid for with a resilience dividend. And so the policy question is who pays and who understands what that value is, because otherwise it's somebody else's job to worry about it.
That was going to be my next question, actually. I mean, if you're talking about privately commercialized, commercial-driven, profit-driven infrastructure, because of course it was so privatized throughout the 90s and thereafter, why should policy have that kind of leverage? Why should they be listening to the federal government? Whether they're resilient or not, they're still making a lot of money in the short term.
I mean, so the electricity infrastructure is somewhat unique in the United States in that transportation infrastructure is nearly mostly public. Water infrastructure has a mix, but more public. But electricity infrastructure is mostly private, and that there are regulatory bodies at the state level and the national level that align incentives. But ultimately, the way that policy has a role here is ensuring that all of these actors are communicating, working together, and providing the public the level of resilience that the market otherwise would not produce. And so this is a pretty pure national security imperative. The electricity system is one of the critical infrastructures under Presidential PPD 19, Directive 19. If we don't have electricity, for a few days, we have a problem. If we don't have electricity for a month, as we've seen in some parts of the country, or longer, people get hurt. People die. People are relying on this infrastructure as life-saving critical infrastructure, and so we cannot let both bad actors or climate impacts or even high cost because of this resilience fall on the back of the most vulnerable populations.
Anything you want to add?
I was thinking about in the cybersecurity policy space more narrowly. This is the the primary pain point.
Yeah.
It's a lot of the we would say that cyberspace is the world's largest public good, made up almost entirely of private components.
Yeah.
There is just a tremendously diverse set of stakeholders who are all in industry, almost entirely in industry, who are responsible for that digital ecosystem, that cyberspace. But we also have vanishingly few legal authorities to bring those outcomes, to drive that priority on resilience. And that's been one of the defining challenges of the last couple of administrations. Our team, when I was in the White House working on the national cyber strategy, the defining sort of message was rebalancing responsibility, was saying that we can't keep devolving risk downward onto individuals and small businesses and asking our grandmothers to be the first last line defense against the world's most capable hackers, right? Like the easy thing, the secure thing, the default choice should be the first thing. It should be the lazy choice every time. The system should be architected so you can't make the kind of mistake that a individual did at Colonial Pipeline that snowballs into a geopolitical incident. That level of individual vigilance should not be required for our world to keep ticking. And we similarly had said that the era of a voluntary approach to cybersecurity, of purely voluntary compliance, needs to come to an end. That public-private partnership has been a tremendous asset in the digital technology space. We've learned a ton. We've gotten a long ways through that partnership. We're not going to get the rest of the way to where we need to go. The outcomes are too inconsistent, and it's producing too many bad events. And so we set as national policy that every critical infrastructure sector needs baseline cybersecurity requirements. It should be customized to that sector. It should be built in collaboration with industry and with the knowledge of the particular risk profile of that sector. But there needs to be just a minimum expectation of cybersecurity. Unfortunately, much easier said than done. Some sectors have all the legal authorities we need. Other sectors, it might be unconstitutional. Where we need to work on it. And so the American system has very different sets of authorities for various different sectors. And a lot of our work is trying to find ways to push square pegs through round holes and all of that stuff.
So what's potentially unconstitutional?
There are certain infrastructures and utility operators on the state level that are
state, federal.
Right. Yes,
yeah.
That the federal government can't reach down and say you have to do this, or our ability to do so is extremely constrained. One painful example is the water sector. Which is made up of thousands of local utilities around the country with extremely narrow margins of operating revenues, and the federal government has very few legal authorities with which to set standards. And one of the very few is a sanitation survey that is administered via the EPA. But basically, like, how many parts per million of chlorine do you have? Are you below this level of lead or this level of microbes? And it is, it's even just that, a survey, right? We just want to know what your stats are. And there was an effort to add a cybersecurity question to that survey, recognizing that increasingly these are remote facilities. We need to digitize a lot of their operations to make them more responsive, and we don't need to have tons of people manning all of these extremely remote facilities. And so sanitation is increasingly connected to cybersecurity. But that hit a lot of legal speed bumps. It is not currently the law of the land, and we're likely going to need to come at it from a different way.
Okay, well, let's shift us ever so slightly and talk about China. China is much more dominant than the United States is on most of the key clean energy industries, producing most of the clean energy products.
That is an inconvenient reality of the transition, but one that I think we have the tools to navigate. The good news is that China is not as dominant over these a number of these technologies as they were in semiconductors, right? So we don't have as much. I'm counting China and Taiwan in this calculus here. So we don't have as much ground to make up, but still pretty dominant. The good news is that, and Costa can speak to this much more authoritatively than I can, that we're making great progress on reindustrializing around a lot of those. On the specific kind of technology security concerns we might have on things that we're importing, I think that, yes, we should take into consideration the risk of importing some goods from a government with whom we don't always have great relations. We shouldn't overdo it. We did some work to try and think through a risk spectrum of the technologies we're talking about here. Like where's the low end where, like, yes, we're importing that from China, probably will for the foreseeable future, but we needn't worry about it. And what's the high end of that we really need to have total confidence in, be able to audit very closely, and ideally have our own supply down the line. And that's easier said than done, but Costa and I kicked off a process that has made progress in identifying some of those technologies. The administration earlier this summer published a list of 5 linchpin technologies to the near-term success of the clean energy transition that are also disproportionately digitally interconnected. And so that's one first step there. And these are technologies like batteries, like inverters, and virtual power plants and software distribution systems. But I think that the next step will be thinking about, well, our solar panels, which again overwhelmingly currently manufactured and assembled in China, we're making great progress on reversing some of that lopsidedness. But how much of that is basically commodity panels that don't have a ton of risk vector to them versus things like software products that are going to directly control and manage gigawatts on the grid on the other end of that spectrum. So I think being empirical and rigorous about risk rather than, oh, it's from China, and being scared of it is, I think, the way we need to go.
Okay. Costa, the Scott Energy Institute, can you tell us some more, tell us a little bit more about how you're working with stakeholders we might not have considered, or things that you feel that you're making a great deal of progress in it? It is such a huge problem. I mean, you laid that out as a mega problem. So, give us a few more glimmerings of hope from the Scott Institute.
Well, one of the things that we did last year before I joined, as our Associate Director, Valerie Karplus, it convened a quarter of global steel production represented at Carnegie Mellon to say, how do we get down to zero emissions? And Pittsburgh, with its roots in the steel industry and its roots in innovation, and that's one of the things I like to talk about when I'm talking about energy in Pittsburgh, is we are surrounded by the kind of great inventions of the past, and we don't have to leave them in the past, or we don't have to be done with that. And so the things that we're thinking about in steel is, making cost competitive, high quality, zero carbon steel is a possibility. Like, we can do that, and the work that we do here at Carnegie Mellon to understand how we can better electrify parts of the steel process, or use hydrogen in the steel process, or have carbon removal as part of the steel process. Those are things that we can say they're technically possible. They potentially could be economically possible. They could be possible on the system side. We just have to get those people together, arranged to make sure that the policies line up with the demand and the line up with the decisions of these firms. The other thing that we are working on is, how do we do beneficial residential electrification? So you all might have a natural gas furnace, if you're here in Pittsburgh, or a natural gas water heater. A decarbonized electricity system and a decarbonized residential system is going to require heat pumps and heat pump water heaters and potential electrified end-use appliances. Well, those technologies exist. I have a heat pump. The challenge has been the social adoption of these. Either the cost is high, there's policy considerations between landlord and tenant challenges, or capital constraints, or even just information. I know way more than I wanted to know about the Inflation Reduction Act, right? When my mother-in-law's air conditioning broke, it still took me a decent amount of time to navigate where the incentives are, what she qualified for, how does it work, what she should get. And oh, by the way, it's 100 degrees out and there's an elderly person that needs an air conditioner. And so we at Carnegie Mellon are thinking about ways to make it plug and play for the energy transition across the consumer landscape, and also make sure that, again, really hammering home that it cannot be only for higher income families. It has to be, decarbonization has to work for and be for everybody.
So doesn't that mean you have to get involved in how local governments communicate with their own citizens? I mean, you have to get into the nitty-gritty in communication, not just what you can plug and play physically, right? So how do you do that?
Oh yeah, the tech part is the easy part.
Yeah.
The social science part is where the actual innovations we need to work on is, because that is the stuff that people are busy, right? I love looking at heat pumps, but maybe not for whatever reason. Not everybody loves looking at the specs of a heat pump, and so we work with companies, and we have a grand challenge partnership at the Scott Institute with a major heat pump manufacturer, air conditioning manufacturer, Train Technologies, to understand how those can serve as virtual power plants and how innovation can help drive beneficial residential electrification. So we talk to companies, we talk to governments, we talk to researchers to make sure that it's not just the same old engineers show up with a solution. Why isn't everybody loving our solution? It's here's a bunch of technical pathways. Here's the things that need to get solved. Even if even if there's proverbial $20 bills on the ground, finding ways to get people to pick them up in ways that help them.
Great. Well, I often have to tell engineers that. It's not just...
Me too.
All my brothers are engineers. My whole family are engineers. I love all the engineers. Okay, so how do you see the Scott Energy Institute and Carnegie Mellon Institute for Strategy and Technology collaborating and cooperating together going forward? We're new. So what do you see as ways that we can make a difference together?
So we were thrilled when we heard that you were joining, and that this institute really is a national treasure in the way that we're training students to understand these global issues. And so we at the Scott Institute are committed to making sure that the way that the energy transition unfolds is something that works for communities, also works for the country. And so some of the things that we were talking about on industrial strategy, I think that the administration I know that the administration, from the very beginning, realized that the energy transition has to work for every community, and that the political economy of the energy transition is just as important or as important as the technical or the economic part. And so making sure that as we navigate a world that has increasing threats from climate change, has increasing threats from state and non-state actors, all while the critical defense infrastructure of the energy system is being rebuilt while we're using it, I see a deep partnership between the Scott Institute and CMIST in ensuring that our leaders at the federal, state, and local level, our companies, our students, and the nonprofit sector understands how politics, strategy, industrial policy, industrial strategy, decarbonization, and security are not siloed interests. These are one thing that we need multiple different types of experts that are working together, rowing in the same direction to achieve our highest aspirations.
Sounds great. All right, we have a few minutes for questions from the audience. So raise your hand and you will receive a microphone. I'd appreciate it if you would wait for the microphone before you begin the question. Over here on the left, please.
Oh, that's convenient.
Howdy, got a softball for you, easy one to start out. So how do we see the authorities to actually conduct cyber defense happening if there is a concerted effort to attack the United States in cyberspace, possibly in conjunction with a conventional attack or other attack? Who's in charge? What authorities are there? And what's the role of that body that's in charge and coordinating with civil defense and the private companies who just have to secure their stuff?
So the bad news is that it's all extremely complicated. The good news, yes, right. The good news is that it's increasingly getting written down and practiced. I think some of those incidents that I mentioned earlier on in the administration were not only illustrative for our thinking on clarity of threat, but also on how well practiced we are at procedures of knowing who to call, who's on first for what kinds of efforts, and prompted a lot of refreshing on that. We're also learning how better to compare notes with industry, with the private sector and civil society about that, to make sure, hey, when we say we're going to do this in the event of a crisis, do you know what that means? Do we have the same understanding of that? And so there's more and more simulations, more and more practice sessions all the time. There's, the U.S. government, as we were talking about legal authorities earlier, being divided in lots of different ways that perhaps I would not myself design if I were starting from a blank sheet of paper today. Nonetheless, they're prompting folks inside government to sit down and say, okay, if X happens, which one of us is the first phone call that industry should make? If there's a X kind of ransomware attack or whomever, like it took a number of years of debate for everyone to just agree, like, oh, you think you've been the victim of a cyber attack? You should call your local FBI. Like, easy peasy.
You're talking about like a little Microsoft Clippy guy, like there's
exactly.
like a post-it note saying that.
Yeah, right.
I'd love to have a little bit more than that. So what's happening next? I'm sorry to interject.
Yeah, right. Yeah.
So just let me make sure that are we good? Like, what do we need to do next?
So I think what we need to do next is we need to build on one of the biggest pieces of cyber policy legislation in recent years, which was requiring incident reporting. This is also another kind of like one of those things that you thought might have had already been the case, but actually was a knockdown, drag-out fight to make the case that critical infrastructure owners, operators now, when they suffer a breach, when they know that they have been penetrated, they have to report it. That precisely, the contours of that, over what timeline, what constitutes knowing, and where those notifications go, That's all still part of rulemaking processes. But at least now we have this expectation that that infrastructure operators and owners should come clean and make sure at least government knows that this has happened. Because a lot of our ability to learn about nefarious actors and their methods and how to adapt to them is only as good as the knowledge we have. And a lot of cyber incidents, some think most cyber incidents, go unreported. It's too embarrassing to talk about, so we're not going to say anything. That expectation should be, this is now just Harry Kresa speaking, that expectation should flow further out. It should not just be the critical infrastructure owners and operators as we traditionally define them, but also your big institutions that hold lots of data, lots of your personal information, that there should be more of an expectation and likely a requirement for disclosure and reporting of those kinds of things.
Yes, but data is money.
Indeed, which is why the market will not necessarily produce optimal outcomes in this case.
Okay, good. All right, another question. And I forgot to ask you, please, when you ask a question, explain who you are and where you're from. Over on the left with the blue shirt.
Thank you both for a great talk. My name is Faris. I'm a master's student in the Energy Science, Technology, and Policy program at CMU, my final semester. I've been trying to formulate this question in my mind for the last 3 minutes, so bear with me if it doesn't come out very clearly. Where would you place the United States energy policy strategy on a scale that would range from highly collaborative to highly protectionist? Highly collaborative would be, if we have lithium, we're okay to export it to many people. We're willing to import key minerals, other resources from many other countries, Canada, whoever. Highly protectionist would be if we have important resources, we're keeping them. We're trying to onshore manufacturing, et cetera, et cetera. Where would you place the United States on that scale?
This is a very good quantitative question that we would expect from our energy science and technology master's students.
Well done.
Which is another great program that we have here at Carnegie Mellon. So I'm always closing here. You got to go find that program. I think the United States right now has what I would call smart openness and smart collaboration, and that we know that a completely unrestricted energy transition introduces more risks than probably benefits along a whole host of dimensions. But that a completely closed energy transition strategy, it also could be, have very bad outcomes for the United States and for our partners and allies around the world. And so I think that the smart collaboration is knowing where our comparative strengths are, ensuring that the energy transition is rapid, equitable, just, and leaves nobody behind. And what does that mean is, finding the types of industries that we need to be producing locally, that we can grow here, that we can use our comparative advantages in AI and robotics and very high, skilled labor to produce the types of products that we will use here and then send abroad, and then collaborate with partners and allies to have those types of technologies available to Americans so that we can have the type of energy system that we need, right? And so I keep thinking about we really need outcomes, right? The outcomes is it's got to be clean and cheap and not get hacked and not burn in a fire, right? And not go out when it's cold, right? I mean, so these are all the different attributes of an energy system, some of which we're doing better than others. The way that we interact with partners and allies is going to affect the flow of that. But we also need to be thinking about the stock of the stuff that we have to make sure that that stock is secure.
Any questions on the right side of the room? The left side's really outshining you all. So anybody over on the right? Yes, with the checked shirt, please.
Hi, my name is Colin. I'm a business student with Modern International Relations, my senior year. So I was just curious about the policy and safety implications of the attacks in Lebanon with the Israeli shell companies used for pager explosions, and what that might mean going forward for potential proof of concept for bad actors? Like obviously Israel is one of our allies, but if this thing if it shows that it could happen with other bad actors.
I think that it's very early for us to know what all the insights and lessons learned are here. But I would posit that it looks like this was more of a supply chain manipulation kind of effort than a cyber sort of effort. But the expertise involved in pulling this off was considerable, and I think also demonstrated a proof of concept that others may be able to learn from. So I think at the same time, it seems like it was a fairly niche situation that made it possible, right? Like extremely old technology that was possible to manufacture or adjust in ways that was not easily detectable. Lots of stacking variables that made this a very kind of customized edge case here. And so indeed, wow, look at what's possible. But also, this was only possible because of this extremely narrow use case. So I don't think we yet know which of those dynamics is going to dominate. But certainly, I think it's going to be the Helen of Troy launching 1,000 op-eds here in the months to come. Yeah.
Quite so. All right, good. And there was a question over on the left with the black shirt there, please.
Hello, I'm Adrian from the Energy Science, Technology and Policy Program 2, my final semester. I do have a question. My question is, how does the US protect its power grid from cybersecurity threats that could arise from smaller businesses or contractors that are involved in clean energy projects, particularly as the country invests more in renewable energy and collaborates, and these companies collaborate with the utility and with the big energy companies here in the US?
That is the question. Yeah. It is, as we were talking about earlier, one of the most exciting things about the clean energy transition is all the new entrants bringing new perspectives and innovation and dynamism to the space. It's also one of the biggest risks that we're needing to figure out how to make sure it remains an asset and not a liability. And I think that the way that that we make sure that doesn't happen is through standards building. It's through coordinated action and activity and among that community. It's trying to figure out what right looks like, what best practices should include, and finding ways for that to reverberate outward. Ideally, we would already have the National Institute of Standards and Technology having mature standards for this whiz-bang new technologies that we're putting into our infrastructure. But in many cases, we are running ahead of that process because we need to. Because we need to cut down our emissions faster than traditional standards-making processes can allow. And so I think that figuring out what best practices look like and cultivating those informally in comparison to standards building is one of the best tools we have. And further, I think just building intuition and knowledge among that community for how to think about this is the other one. I think that just bringing enough of these vendors into the same room and having the same conversation about how they're each thinking about this is a big part of the solution. I think getting utilities to coordinate on what their cybersecurity asks are of new connections and sites would also make this a lot easier. It is the social science grind of it that I think is going to be the bigger part. What do you think?
Oh, I was going to add to it. As much as we need to be advancing our cybersecurity of the electricity grid, we also can't forget the physical challenges of the grid, the physical security of the grid. Carnegie Mellon a few years ago led a national, authors from Carnegie Mellon led a National Academy study on the physical risks of the grid. And those include the people who want to do harm to the grid by a kinetic attack, by shooting at it, right? And that people do that more often than we would really want to happen. That can cause real damage in different parts of the grid. But it's also the ways that the grid interacts with the environment even before climate impacts. So, squirrels and animals shorting out parts of the grid is one of the major causes of electricity outages. And then the other part is trees falling on power lines. So, like, if we can't handle trees, like handling a hostile foreign intelligence agency is going to be really difficult. So we're going to have to figure out our physical risk, our cyber risk, and then our climate risk. And what our climate risk is extreme heat, extreme drought, fire, extreme rain and weather and wind. All these are physical engineering challenges that we need to be thinking about at the same time as we harden against cyber.
Can I ask a kind of a dumb consumer question? Why don't we have more of our electrical wires underground?
So the short answer is it costs too much.
Okay.
It's easier to hang something up on the wire
Yes.
than it is to put it underground. But the complicated part of this, and the costs are coming down from that, and a lot of places want to do that. The complicated piece is during Hurricane Sandy, a lot of lower Manhattan's electrical infrastructure is underground, or at least on the basement level of the first floor, and it all got flooded and it all got destroyed. And so there's challenges in areas that have flooding when you want to put stuff underground. There's also challenges just in general maintenance. When you want to fix something and the power lines are underground, now you may not be able to get to it. So there's for sure opportunities to underground our power lines in many parts of the country and in places that have the types of risks and the types of opportunities that don't preclude doing that. We should be doing that. But at the same time, like everything in this business, it's a function of money, but it's also in some places we just can't do it physically.
Well, like here, because so much of the underground is rock, right?
Yeah, I mean, we could do it in Pittsburgh. The bigger challenge is that I think I would start by undergrounding places where there's high wildfire risk, like places like out west, and where I don't have a lot of flooding risk at that level.
Okay, other questions? John, here in front.
Hi, John Chan, faculty member in CMIST. My question is about what should the top priority, I guess, in terms of climate diplomacy and advancing the clean energy transition, right? So you mentioned the Paris Accord, and so we have this nationally determined contribution and great goals, but to the question of sort of international collaboration, is there more deal making? Like what does the U.S. need to do sort of internationally or cooperatively to try to advance the agenda?
I think the rejoining of the Paris Agreement and the inflation was expected. I think the Inflation Reduction Act was not expected, and what that did was create a friendly, spiraling competition between us and partners and allies to figure out how serious we are about dealing with climate change. And I think that the way that the EU has now reinvested in their own climate action largely because of the Inflation Reduction Act, is a way that competition and collaboration between partners and allies can drive more emissions reductions than we otherwise could have had. I also think that there is a multi-trillion-dollar opportunity across the entire world that all countries should be able to participate in. That climate diplomacy it needs to be leading so that it cannot be only the richest countries benefiting from the opportunities of a decarbonized world. And so a big part of climate diplomacy is ensuring that there is a coalition of partners and allies where everybody feels that, again, same thing that we deal with in domestic politics, is everybody feels respected, included, and seen as part of the opportunity of the clean energy transition. I'll also say that it's important that we in the United States and the folks around the world don't feel like that climate is done because we got the Inflation Reduction Act. A lot of times in policy, it's like, if we can only get this one thing done, then we can move on to these other challenges that are really coming at us at full speed all the time. Things that we haven't talked about today, around healthcare and safety and education and the economy. Climate is upstream of all of those, and so the Inflation Reduction Act was the greatest climate bill that we've ever done so far, right? And so we have to think about it in those lanes of what else do we need to be doing to create the industrial strategy that enables both domestically and with our partners and allies a continued coalition that advances towards decarbonization. That is a long way of saying, like, yeah, it's complicated, people got mad at us, but I think that there's opportunities going forward in international trade, sometimes of technology, sometimes of clean molecules and fertilizer, that there's an opportunity for everybody.
I think that friendly spiraling competition that Costa mentioned is also with a lot of countries with whom we have pretty good cyber diplomacy relationships. And if we're able to create a network of interrelated industries and supply chains that are observing some of the same norms of auditability, of security and resilience that we've been working towards in other sectors of our economy, then we can hit multiple birds with one stone. That's not very climate friendly. I should look for another analogy, but yes.
Well, may I add one more thing is because science, technology, and research have a big role to play in this. And so there is something that Secretary Kerry set up in the First Movers Coalition, Mission Innovation, where a bunch of countries are working together on big climate science and technology challenges to work with industry to solve those. And so these are ways that climate diplomacy is S&T diplomacy, as well as kind of international trade diplomacy. So at COP28, we launched an international strategy for the cooperation on fusion energy. And so that is something that is pre-commercial, but has opportunities for the world scientists to collaborate on a potential exciting new technology that ensures that together there's a greater chance of solving some big challenges than trying to do it alone.
Okay, we're just about out of time. So I can take 2 questions, maybe as a group. There were a bunch of hands a minute ago, but you've given up now, huh? Middle? All right, we'll close. All right, 2 questions, one in the very back, and then your question, and you guys can decide which ones to answer.
I'm curious about, before previously mentioned that during
It's difficult to hear you. Can you put it up?
Oh, yeah.
And
During
tell us who you are.
Oh, yeah. I'm a master student in Heinz Public Policy and Data Analytics. I'm curious about during the decarbonization process, you say technology part is easier, but the social science part is difficult. I don't understand fully, so can you explain it? And the second question is about, can you introduce the intersection between the cyber data and the energy transition, the intersection between these things? Yeah.
Great. Okay, and then in the 4th row up here, Rosalie. Oh, you got it. Okay.
Yeah. So my question was, solar incentives or like renewable energy incentives are one of the reasons why people are okay with transitioning. Will we ever reach to a point where we don't need these incentives and yet businesses would willingly want to continue and invest in renewable energy sources?
Okay, who's starting?
So the first question from the back is, why is technology easy and social science hard? There are, for sure, big advancements that we still need in technology. We launched the President's Net Zero Game Changers Initiative to do exactly that, to kind of make those types of advances. But even the best technology in the world doesn't reduce emissions unless somebody uses it. And so that's what I meant by that, is like we have to make sure that even after we're developing the technology, we have to make sure that we get people to use it. And then to the question up front about solar technology incentives, this is something that I've been talking about, and our economist friends in the room will throw tomatoes. We should be subsidizing clean energy until emissions are below 0. And so the reason is we subsidize things that we want more of. home ownership, education, national security, other things. And we want more clean energy than the market is providing, even if solar is the cheapest, which it is. So we're going to have to over-index on clean energy to make up for the lost time that we have in the clean energy transition. And so we will have to, and we should be, there's a policy rationale for subsidizing clean energy and through 2050.
But you know, no tomatoes.
Yeah.
That's right. Well, and I think to that point, the countries around the world that have passed like cap and trade systems and like carbon taxes have either seen them fail or get immediately repealed. And for more of those economist tomatoes, it seems like basically just carrots all the way down, no sticks, is like the actual real world solution for a lot of this. I think the question was about like about data and the clean energy transition. And one of the examples that I like to point to is the kind of granular information about how electricity is used, like at the end by the end user, whether that's a resident, whether that's a building, a manufacturing plant. There's a ton of useful knowledge about how electricity is used, when, and in what intensities. That is extremely important to utilities doing a good job of sending electricity where and when and at the right times, and informs things like virtual power plants, software-defined distribution of electricity that is probably going to get more important in the years to come as we add more variable sources of electricity with storage and have more electrification of heavy industry and EV charging. Like knowing where to send power when and in more precise quantities and timing is going to be really important, and is going to depend on trustworthy data and software, secure and resilient software. And if too many pieces of those pipelines get broken, or bad information is sent at the wrong point, then you can suddenly be sending way too much electricity to a point that then you should, and that could be damaging. I think a lot about how electrification of heavy trucks and freight near the end of this decade is expected to require extreme fast charging is the term of art. And for like a semi-truck to be able to charge its battery in the same kind of 15 to 30 minute range as like a passenger EV is going to require like a small town worth of electricity, blipping on and off the grid. And we'll need to have the confidence that our grid is going to be able to know and handle that variability of, cities worth of electricity getting called down and then shut off with great variability across like the I-95 corridor. And I don't know if we have that confidence just now.
Yeah. That's terrifying. All right. Well, let me just say that I want to speak for CMIST, that we are just as excited to work with the Scott Energy Institute as you expressed, and I hope that we can continue to do this. And we're super excited that Harry is with us, just having joined us about 2 weeks ago, I think.
That's right, yeah.
And he's our human bridge to the Scott Energy Institute. But I know that we can collaborate in the true Carnegie Mellon University tradition and move this conversation forward. So thanks to both of you. I learned a lot here, and I can see that we have an agenda that we need to work on together moving forward. So thank you, and thank you to the audience.
Thank you.